Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, today's question is MINST. In this question, we begin by an integer x equal to 1 and we're allowed to do one of these two operations. So in each operation, we can either multiply the x by 2 or we can add this number d to our x. And we need to find the minimum number of steps to make this number x equal to n. And if it is possible, we need to print -1 instead. In the constraints, we are given that the number of test cases will be in between 1 and 1000. The value of n and d will be in between 2 and 10 is to the power 18. D can also be equal to 1. So this is pretty much the problem statement. Let us once see the sample input to understand it better. So in the first input, we're given 6 and 2. So we need to make n equal to 6 and with d equal to 2. So we begin by x equal to 1. Now the most optimal way is to add this number d to our x. So our x will become 3. Now we'll multiply this x by 2. So our x will become 6. And it took us two operations. So we'll be printing 2 in our answer. In the second, we're given n as 4 and d as 3. Initially, we have x equal to 1. We'll simply add this number 3 to our answer to our x and we'll get x equal to 4. And we just made one operation to make x equal to n. So the minimum number of steps is 1. In the third input, you can verify that it is not possible to make x equal to n ever. So we'll print -1. So yeah, this is pretty much the problem statement. You can just try out the rest of the test cases yourself if you want to. But now let us move to the solution. So notice here that what are we doing at every step? We're either multiplying it by 2 or adding something, right? So if initially, let us say we had some x, we'll either add some number d or and then maybe add again, and then multiply by 2, then maybe multiply by 2 again, then maybe add d again, then maybe multiply with 2. So this is something we'll be doing, right? So in any valid sequence, we'll be trying to first of all add some number d, then some number of times we'll be multiplying with 2, then some number of times we'll be adding d again, then multiplying with 2 again. So we're doing this step repeatedly, right? So instead of doing it repetitively, what we can do is merge them and say that we added 3 times d with a cost of 3, or we multiplied by 2 square with a cost of 2, or if there was another 2, we multiplied it with 2 cube with a cost of 3. And that is pretty much the same thing, right? Just modified slightly. So what we'll say is instead of whenever we are adding, we'll be adding a times d, and whenever we are multiplying, we'll multiply with 2 raised to the power b. So how does this help us? So now we don't need to consider that we can either add d or multiply with 2. Now we'll be always alternating between adding some ax times d or multiplying with some 2 raised to the power 2 raised to the power by, right? So let us see it now. So let us say initially our x is equal to 1. We'll be we'll be adding some number of times d. So we'll be adding d some a1 number of times. So we can say that we have added d a1 number of times, and this a1 can be 0 to represent that, okay, we did not start with adding, we multiplied with b1 first. So now after one step, our x would become this, right? After two steps, we'll be multiplying with some 2 raised to the power b1, right? So if we multiply it with 2 raised to the power b1, we'll be getting this. Now we can add some a2 times d again. Then we can multiply it with 2 raised to the power b2, right? We can multiply whole of this equation with 2 raised to the power b2 and we'll be getting this. Then we can again add some d times a3. Then we can again multiply with 2 raised to the power b3 with through all of this expression, right? Now, can we say that, like, we can easily see a pattern, and can we say that in the end, our n would look something like this, where this k1 is the sum of p1 plus p2 plus p3 dot dot dot, and over here we have k1, k2, k3, kx, and so on, right? And can we say that what are the number of steps we require? What is the answer? It is going to be k1 plus a1 plus a2 plus dot 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 ax. Why? Because k1 is b1 plus b2 plus b3. And what is b1? So b1 is the number of times you multiplied with 2 initially. Then b2 is the number of times you multiplied with 2 again for the second iteration, right? then b3 is the number of times you multiplied with 2 some next number of times, then b4 would be the next time, then b5 and so on, right? So we can say that this k1 is the number of times in total we'll be multiplying it with 2 plus how many times did we add the a1 number of times, then a1, a2 number of times, then a3, then dot dot dot, then ax number of times, right? So in total, we'll be adding this a1 and this will be adding this t these many number of times, right? Can we say that our answer would be this? And now we just need to minimize these k1, a1, a2, and dot 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 up till this x, right? How can we do that? So we know that there's a threshold on k1, which is going to be equal to 60 because 2 raised to the power 60 is greater than 10 raised to the power 18. So our n is equal to this, and our n is bounded by less than or equal to 10 raised to the power 18. So this 2 raised to the power k1 also has to be less than or equal to n. So it also has to be less than or equal to 10 raised to the power 18. So the maximum value of k basically can be 60 only. Now we can just try to brute force over all of these values, these possible values of k, and we can just minimize our answer over all the possible values. And if over all the possible values the answer does not exist, we can simply print -1. Now we know that our n is equal to this thing, and this k1 is fixed from our loop from 0 to 16. Now n minus 2 to raised to the k1 upon d would be equivalent to this. And now for this to be valid, n minus 2 raised to the power k1 has to be greater than or equal to 0 and divisible by d, right? Otherwise, it just does not make sense. Now, what does this remind you of? It is some addition of some 2 raised to the power keys, right? And we know that k1 has to be greater than k2, has to be greater than k3, dot, dot, dot. Why? Because this is k1 is this, k2 is this, k3 is this, and so on, right? So, and we also know that we can represent any number as powers of 2, right? So we'll be easily able to represent this number as well, right? And it's a very, very common trick that we can easily greedily take the largest power of 2 as many times as we can and just keep on taking them to minimize these a1, a2, a3, and so on up till x, right? So what we'll do, we'll just let us, if this number is equivalent to some number z, we'll divide by 2 raised to the power k1 and see how much a1 we need. So the value of a1 would be the floor of z upon 2 raised to the power k1. And now our new z would become z modulo 2 raised to the power k1 because we have already taken that many of them. And we can just repetitively do this step and we'll get the sum of all of these a1s and update all of them. And we can just add all of them and get our answer. Now let us see the code in C++ and Python. So this is the solution in C++. We take in the input of n, d, and all the test cases. We initialize our answer as n plus 1, which is nothing but infinity. Now we just run a loop from 0 to 60. It could also be up till 60, and that is totally fine. We have defined this x to be the power, the 2 raised to the power I. If this x is greater than n, that means it's just not possible now, so we can break. Otherwise, this y is n minus x. We check if y is divisible or not. If it is not, we continue. If it is divisible, we divide it by t. Our cost initially is equivalent to this I, which is nothing but the number of this 2 to the power k1. Now, we repetitively take the largest power of 2 if we can, and then just take the remainder. And in the end, our answer is nothing but min of answer comma cost. And if we could not find any answer, we print -1, otherwise we print our answer. Now let us see the solution in Python. We begin by taking in the input of n comma d. We initialize our answer as some very big number, so this would represent infinity. If our n is smaller than 2 to the power I, we break. If we define y as n minus x, if y is already not divisible, we continue, or if it is divisible, we divide it by this number d. Now our cost initially is I, which is nothing but this value k1. Now we run j from this I till 0, and our cost, we add this floor of y upon 2 to the power this j, and then we take the modulo, and in the end we just take the answer as min of answer comma cost. If our answer is very big number, if we could not find any better answer, we print -1 because it's not possible. Otherwise, we print answer. So yeah, this is pretty much the whole solution. I hope you liked it. Thanks.